Hi everyone. Hi. So I'm going to be talking about NPM and secure software in an open source world, which is kind of a mouthful. My name is Karl Düüna. I'm CTO at NodeSWAT. I'm also the author of Secure Your Node.js Web Application, and you can find my social profiles on the slide. I don't know if you can see them though.
Beautiful.
It's beautiful, yes. We also have Apollo popping up here. So what am I going to be talking about is basically NPM. What our main concerns were when starting out this project. We have an internal project called NPM Shield. How I did an analysis on NPM, what interesting things I found and what problems I found, and what are the current possible mitigation solutions. So let's start with NPM, or Node Package Manager, as I prefer to call it. Although their frequently asked questions thus state that they are no longer Node Package Manager. They have over 270,000 modules as we speak. And according to a recent blog post, they had there are over 4 million users and about 1 billion downloads per week. And that doesn't include the ones that hit the cache. So NPM is big. And we all know it, we all use it. So what were my main concerns when I started out is basically we start with the control. You have very little control over the whole dependency process. You can choose what you depend on, but then they have dependencies and those have dependencies and so on. Also, there is the uptime. I don't know about you guys, but I have run into a problem when deploying somewhere that NPM is actually down and the deploy fails because of that. They have done great work on bringing up their data centers, and now they have a lot, as we can see here. Next up is the size of the trust chain, or how many people I trust when I install a dependency. And actually, here's a bit of preview from the analysis that I did, that an average module actually contains 42% original code and 58% is dependencies. So if you install something, then you're trusting not just the person who wrote that module, but all the other ones as well. And that ends up to a lot of people. And of course, then there's the question of consistency. That can you be sure on what you're installing? This mostly comes up between your development and some other development machine or live deploy when you're downloading from NPM, because mostly in package.json we have version ranges, and so you don't really know what you're getting. And those of you who are crying out shrink wrap, which I have mentioned here, shrink wrap actually doesn't solve this issue 100%. There are about 1% of cases where you can actually, in package.json, have dependencies that point to external URLs. And shrink wrap does nothing to help with those, because you have no idea what this URL is going to serve. And some people even point to master repositories in GitHub. So whenever somebody does a push there, you're going to get a new version. And shrink wrap helps nothing. And of course, when we're coming to the security part of the topic, then we have modules that either by design or by negligence have security vulnerabilities. And according to SNCC, which is one of the leading software that checks for those things, there are about 14% of modules that actually have a vulnerability that is already known. So the current solutions also include Apollo Cinemas, apparently. We have Node Security Project or Node Security Platform as of last week. They actually changed their name as they now came up with the paid-for tools. So they got a business model built around securing your dependencies. They have an awesome community and they are really supported by Node.js. And then we have SNCC which does pretty much the same thing, except that they also provide patches for those vulnerabilities. Now, looking at these two tools, they both are awesome, except for the fact that both of their databases consist of around 100 vulnerabilities. Now, if you consider that there are 270,000 modules and only 100 vulnerabilities, then something doesn't add up. So that was one of my motivations to start this. So in NoSWAT, we created a pet project called NPM Shield. It is not yet ready to be introduced to the world, but basically we want to try and help fix mitigating these things. So what did I do? I started by cloning the whole NPM repository, then downloading all the packages, running some analysis on them, and then we, of course, find a nice way to help everybody. It sounds a lot easier than it was, because there are a lot of edge cases in NPM. There's not a lot of checking on a lot of things. For example, NPM doesn't even check that the semver that you publish is valid. So at some point you run into occasions where the semver that the NPM serves you is invalid and it breaks itself. So a lot of edge cases to cover. But I did it and I found out a lot of interesting things. So first of all, the size. At the moment of analysis, which was about 2 weeks ago, there were 271,000 modules. That accounts for 1.65 million different versions of those modules. The whole size of the database is only 2 gigabytes, which was surprising for me, but that's in zip format. And the whole size of the code was around 600 gigabytes. And an interesting thing I found out from the get-go is that there are a lot of packages that actually do nothing. Those are people who actually created a package thinking that they're going to do something cool, then they reserve the name, and that's all they got to. So about 2% of the package is empty air. Next up, we have a lot of metadata, which is one of the things that I found, one of the more interesting things. When you are installing things with NPM, say, for example, Express, the latest version, then what NPM does is in the background, it downloads all the package JSONs for all the versions of Express. So you get everything. And then it chooses the last one and then it downloads the code. So there are situations where you actually download more meta information than you download code. And that actually is on about 7%. And in the worst case, you get 22 times more meta information than you actually get code. So this is one fun thing. Another one is that NPM actually doesn't do parallel downloads and installations. What it does is does serially. A nice alphabetical download process. I created a GIF for that. And basically, if you're ever wondering why your NPM install is slow when your internet connection is fast, then here's the reason. But now, getting to more important things, here are, well, this graph is awful, but here's a nice pie chart of all the different licenses that the modules have, which is of course important when you're doing something for commercial reasons. And if we look at it, then most of it is MIT. Then there's a large chunk that is nothing, and then we have a lot of different things. My favorite one is What the Fuck PL, which is actually a license called Do What the Fuck You Want To, public license, which is surprisingly popular. There were like 4,000 modules that have this, so it's kind of awesome. Now coming up to how new actually the modules are in NPM repository, then the average module was last updated over a year ago, more precisely 395 days ago. So things in NPM aren't that new. Those are pretty old and are actually accumulating from the beginning of NPM. So no very updated modules. And Apollo is also trying to get some airtime. So if we do the analysis, then this is what the average module in NPM is like. It was created almost 2 years ago, well, 1.5. It was updated a little over a year ago. It's about 260 kilobytes and has 6 versions. There are about 60 files, and it maybe has tests. I'm saying maybe because the newest versions in NPM, about 50% of them have tests. 50.7 actually have it.
Do you know the standard deviation for those numbers?
No.
Okay.
These are not statistically sound numbers. The methodology probably would require some work, but I was in a hurry. So more importantly, from security perspective, ustrict is not as popular as one would hope. There are only 32% is in use. And even modules that use ustrict don't use it in all their script files. They actually use in only some of them, and then they probably forget in the other ones. Most of the code is in GitHub, which is nice, and most of it's MIT license. So more security-related flags. A lot of modules have changed hands over the years. So the person who started it actually is not the one who's no longer maintaining it. And a lot of them have bad dependencies, and those are the ones I called before that was outside the actual NPM registry. Those are pointing to master repositories and stuff like this. About 2.2% have lifetime scripts that are running when you install or uninstall those modules. And if you look at the down at the page, then we see that about 35% actually use file system, which is quite surprising because I didn't expect so many people to actually use the file system. We are talking about NPM where a lot of modules are also client-side modules. So this is quite interesting. And we also see that from the ones that use HTTP, only half of those use HTTPS. So security, again, is taking a backseat. And eval, although the community has made an effort trying to banish it, we are still at around 6.6% of modules that use it. So more fun things. A module that has the most versions is called Nixar, and they are pushing them out basically daily. There are 834 module versions of that. Then we have something called the Mykolaisenko hoarders, which somebody did, and it has in the package.json 389 dependencies. And all of those are wildcard dependencies. So that's a nice one. Then we have the next one where somebody thought that it's really hard to actually install popular Node modules and collected them into its own package.json. There are about 50 popular modules in there, but since the popular modules have a lot of dependencies, then the whole dependency tree will end up with 1,625 installed modules. So that's a really nice one to install to yourself. Then we have a house, which is kind of a CMS type thingy, but they, for some reason, included a lot of image files in their package. So when you're installing it from the repository, then you're going to be downloading 500 megabytes of stuff and then unpacking it. And of course, the most files we have in a generator is 110,000. And now we're coming to my favorite, which is the largest NPM module unpacked side. And it's 8.6 gigabytes. And of course, it's called Your Mom. And I mean, you got to give credit to the guy. And my second favorite is I found a module with a very interesting name, which is on top of the page. And the reason for this module is it creates a random string. So it's kind of hard to remember, but I mean, there are a lot of weird things in NPM. So let's move on. So what are the main problems that I found is, first of all, we're depending a lot on things. if we look at the top 10 modules that are depended on within the tree, then we see that we are duplicating the language itself. For example, number 3 is isArray. I mean, array.isArray has been in the language for quite some time now. And that's the whole content of the module. It's 3 lines of code. And that's not even the worst one. I mean, if we're talking about Apollo here, if we're actually talking about inherits, which is the first and the most popular of dependencies, then this is the actual content of the inherits module. So thank you for depending on it. But please, guys, do you even remember left pad? I mean, we had this incident like 2 months ago. For those of you who are not familiar with the incident, then I'll do a short recap. There was this guy who had a lot of modules. One of them was called leftpad. And one of the modules that he had in NPM had a name collision with some company who had apparently copyrighted it. And they complained to NPM about it, and NPM actually transferred the ownership of that module to the company. And in protest, he removed all the modules from NPM that he owned. One of them was leftpad. And since leftpad was very popular module, also depended upon a lot, then his unpublishing it actually broke suddenly everything that depended on it. And that caused havoc because for like 3 hours until NPM restored the module, everything was broken and every build and every test failed. So NPM now has set up policy guidelines to avoid these things, but I mean, that doesn't actually stop somebody from publishing a new version which is breaking everything you have. So moving on, this is the problem, we have a dependency explosion. Means I depend on 10 things and those in turn depend on 10 things, and so I end up with installing 100 and 200 or 300 modules when I'm doing my development. Here's a nice graph representation from Express. Of course you guys don't see a lot, but you get the main idea. There are a lot of dependencies.
Did you also have a link for the slides?
Yes, the slides are online at slides.com. I can actually show this. Slides.com/Karl Düüna. Of course you don't see it. My bad. I'm going to continue. Later on, we're going to have the slides up at the meetup.com. So, with the dependency explosion, we also have the explosion of the trust chain. I mean, an average module in NPM depends on 12 modules, and an average number of maintainers per module, that means people who have the rights to push a new version out, is 1.28. The maximum one is 55 actually. And that means that with one module, on average, you're trusting over 15 people with your deployment or your application. So that's a lot of trust for people you have never met. As next up is lack of control. As I said before, NPM is very JavaScripty. I mean, it's not heavily typed. It doesn't do any checking of anything. You can push almost anything into your package.json and it accepts it readily. That means that you can have dependencies to wherever. There are a lot of valid ways to have dependencies. That includes file system paths, GitHub paths, everything like this. This will work fine. But then you can also do things like this that we have on the bottom of the page, which is have a license which has on mouse over alert, which I'm quite sure is invalid, or you have a symbol that points to etc password file. Some people have been having fun with these, and those are actually in the nearing 100 of examples I found. Next up we have scripts, which are one of the pain points within NPM. because you can specify a lot of different lifetime scripts, and those scripts are going to be running with the same rights that the user who actually runs the NPM install. So we have the problem with malicious executables, or also negligence or some corruption that they can really mess up your machine. And this year also somebody published an idea that you could write an NPM worm, which means that since NPM has another bad design, which is that you are kept logged in always. So if you are an author of a package and then you install this, somebody creates a package that on install would actually publish itself again by inserting itself into your package JSON and then publishing a new version of your module, then this would spread like wildfire throughout the NPM, because there isn't much anybody does for that. And you can avoid installing scripts by having the flag ignore scripts or coming to Apollo. And you can also set this flag, but nobody ever really does that.
I do.
I do recommend looking over the modules that you're going to be running with scripts beforehand. So having this is very, very nice. And of course, then there's the registry, which is the single point of failure in the whole system. We currently explicitly trust the NPM registry in itself, but nobody has ever considered that what happens if somebody breaks into the registry. There is no validation on the package that gets downloaded except the SHA hash that is stored next to the package in the repository. It's not going to be very difficult to change the package and the SHA at the same time. So suddenly all the 4 million people are going to be exposed to whoever does this. And it doesn't actually have to be the registry itself, because you can configure your local NPM with the file called npmrc.npmrc. And if I create the module that on install would actually insert into that file a new registry address, which is one I control, then you will not be wiser, but every install afterwards you're going to do is going to hit my registry instead. And I'm going to serve you whatever the hell I want. So this is very bad, and we should be setting up something to validate actually the packages later on, like certificate authority type. So let's come to the solutions, what you can do actually at the moment. First of all, of course, you yourself can be very careful with what you depend on and what you trust. And doing this is not just a favor to yourself and your application, it's actually to everybody else who also uses your code. And I would definitely recommend doing this for the greater good. Of course, next up is ignoring scripts and logging out of NPM itself, so that somebody can't push or publish packages that you have the rights to. And finally, locking your own dependencies. Having packages which depend on wildcard dependencies is a very bad thing. Even if you don't include the security vulnerabilities that can come from this, then having these things can easily break development, testing. When somebody pushes a new version, everything breaks. And of course, you should check your own dependencies for vulnerabilities. There are tools for that. I'm going to, 2 slides down, I'm going to point them out. First of all, coming to the tools, we have NPM check, which is a nice tool that helps you verify your own package JSON. It does validation if your modules are out of date, if you need to update them. It actually even checks your code if you are using the modules, so you wouldn't end up with unused modules in your package JSON, which actually is kind of a big problem in NPM, because there seem to be about around 10% of modules have dependencies that are not even used. But this statistic was not on my slides because the methodology I did for that was a bit skewed, so I have to double check that. Next up we have NSP and SNUC. Both of those have command line tools and integrations for continuous integration mechanisms. So those both check your package JSON and your dependency tree against their vulnerability databases. So you get an idea what kind of vulnerabilities are deep down in your dependency tree. And then there's, for those of us who actually have packages of our own that we published from time to time, the community has come up with a module called Publish Please, which helps you publish clean modules into NPM. It does checks for, again, unused modules, that everything in your package JSON is correct, that we have correct sembers, that your tests, if you have tests, do actually pass, and so on and so on. And then there is NPM duct tape, which is a module that I wrote during this analysis. It's a wrapper around shrink wrap, and what it does is actually it downloads all the modules in shrink wrap and places them into a folder of your choosing in the repository. So you can include actual tarball files within your repository, and then when you're doing an install with this NPM install, you don't actually need the registry at all. The registry can be gone, you don't have to have any type of internet connection. So it's an extra layer of validation around that you get what you want when you're installing things. And so in conclusion, what does it all mean? Well, first of all, we have that NPM is really big and we really depend on it a lot. And there are a lot of implicit trust issues built in within the current system. And it's a community effort that is needed currently to actually have nice security hygiene that everybody can benefit from. Because currently some bad actors can push the security issue very far. I mean, there are people whose packages are so popular that if they get hacked, it's a very big issue for the community because they don't have to be malicious. You are going to need their credentials to push out a new version, and you're going to be compromising everybody who depends on them. And finally, be vigilant yourself with the dependencies that you're going to be using, because we all use a lot of dependencies, every one of us. And I want to point out that not everything is necessary that you're going to be downloading from NPM. Just because it's there doesn't make it useful. And sometimes it's better to actually copy-paste the code into your own module than to actually have it in NPM. And finally, for those applications that are security sensitive, I do recommend doing an audit on the modules themselves. So open them up, look them over, follow what they do, and then you'll be ready to actually deploy them. And thank you. Questions?
Let's take a few quick questions as well.
Yes.
Is there a constructive way to lock down the dependencies that the modules themselves download while they are running instead of using like package JSON?
Let's repeat the question as well.
You mean running while they're running? Or you mean dependencies of dependencies?
Or no, I mean dependencies that execute and then download something that they need during their own runtime?
Yes, no, there isn't at the moment.
Repeat the question as well.
Oh, yes. You wanted to know if there are any ways to lock down dependencies that the packages download during their install. And currently there isn't. NPM shrink wrap and NPM duct tape that I brought out here actually they take the state of modules you have in your node modules folder at the point where you run NPM shrink wrap or duct tape. So if the install script will install it into the node modules folder, then it should be in this file. But if it's not, then there is nothing you can do.
Any other question? Back there.
When to use a module, when to copy paste it in, and when to write it yourself?
repeat
Right.
the question?
Yes. Question was that when is it the right time to copy paste, when there's the right time to write it yourself, and when it's the right time to actually use it from the repository. Well, I would say if a module fits between 50 lines of code, it's reasonable enough to copy paste it. That doesn't mean all the time, but for modules that I showed here, which are going to be static, there's not going to be a lot of updates on array or .isArray. I mean, it's quite crystal clear. Then that is very fine to copy paste. Writing yourself, I mean, I don't recommend reinventing the wheel all the time. But if modules that are out there are not a perfect fit and you're looking for small functionality, then I do recommend you do it. And in cases where there are modules that are out there, but they do 90% more stuff than you actually need, that you only need 10%, then taking this out and publishing it itself for other people is going to be good. And then you have full control over it.
Any other kind of questions? You have.
So it seems that lots of things have been done wrong in NPM. Can you name any examples from other languages or platforms where that is done right?
Where that is done right. The question was, there are a lot of things that have been done wrongly in NPM, and can I name platforms and or languages where things have been done right? Well, NPM is not a language. NPM is just something that somebody wrote. From the get-go, I am not so familiar with other package managers. I'm not sure how they do validation, but I'm quite sure that they don't have this type of a problem where they don't validate the packages that get published there. So doing first-hand is going to be key, first-hand validation before publishing. I'm quite sure that all apt-get and those ones, they do it. I'm not sure about Maven or Composer or stuff like this, because I haven't used them in quite a while.
Let's take one quick question back there.
Do you have any time frame for the NPM Shield?
Yes, we're actually nearing completion on that because it took a lot of effort. We hope to get a working version or something working out in the next month or so. So in the middle of summer, let's give ourselves time because deadlines always push forward. But yes.
So let's take a small break now. We've got 20 minutes. Thank.
Garant.